So, hello everyone, today we are going to start the second lecture of this module, that is on downstream processing. So, today we will be focusing on the first step in the downstream processing, that is solid liquid separation. So, for that there are three major methods, that is filtration, sedimentation and centrifugation. So, we can quickly revisit the last lecture. So, there we discussed overview of downstream processing. It includes all the unit operation after the fermentation till the recovery and purification of your product. So, what are the sequences in the downstream processing we discussed. So, it starts with first separating the solids, particularly the cells. Then again you have to go for cell disruption, then again you have to go for solid separation, then we have to go for the recovery and purification. And in case of extracellular product, after separating the cell, the supernatant is used for the recovery and purification. So, in the case of recovery means you need to concentrate, purification means you want to purify it. So, what we discussed, along with downstream processing, it also adds cost to your product. So, we discuss if you keep on increasing number of steps means you are going to lose your product, at the same time it will be more and more expensive. Of course, if you have more number of steps you are going to have the highest purity, but at the same time we need to have a balance between its cost and purity. Then we discuss its importance and application across various domains in bioprocessing, starting from simple chemicals, let us say alcohols and solvents, to pharmaceuticals, recombinant proteins, monoclonal antibodies, food products and various enzymes. So, today we are going to discuss the first step, that is solid liquid separation. So, there are three methods: filtration, centrifugation and sedimentation. So, we will start with filtration, then we will discuss next two topics. So, solid liquid separation. So, what solid we are going to separate? The solids can be your biomass, insoluble particles or any other macromolecule from the fermentation broth. So, once you are having fermentation broth, you are going to separate the cells and let us say supernatant or it is in the liquid. So, this we are considering as a solid and supernatant we are considering as a liquid, and in the case of extracellular product this will go for further purification and separation. Now, what are the three methods to separate this operation, that is filtration, centrifugation and sedimentation or settling, are also known as decanting. So, first, what is filtration? This is a mechanical or physical process used to separate the solids from liquid or gas using a filter medium. So, there will be a filter medium which is going to separate liquids from solids. Principles: one option is the separation can be based on the pore size. So, particles larger than the pore size of the filter are retained while the fluid passes through it. In this way we separate solids and liquids, and as I told, it is applied in the removal of particles in the downstream processing. In addition, it is also used for sterilization of cell culture media, particularly for mammalian cell. It is also used for clarification, that is a step particularly applied in a wastewater treatment. Now, fermentation broth is passed or sometime it is forced. So, when you are forcing, you need to apply the pressure. So, once you are passing through the filter medium, a filter cake is formed, and that filter cake is basically this is the solids. Now, we can categorize the filter as conventional filter. In addition, there are microfilter, ultrafilter, nanofiltration and reverse osmosis. So, for the first step solid liquid separation, the conventional filtrations is used. This microfiltration, ultrafiltration and reverse osmosis, they are particularly membrane based filtration. They comes in the last category during this polishing or the purification of the product if needed. So, here we consider conventional filtration which involves large particle, the particle size should be greater than 10 micrometer, and for microfiltration it can separate particle up to micrometer, ultrafiltration even smaller, reverse osmosis it can go up to the angstrom level. So, other filtration techniques are considered in purification section. Now, there are two type of filters are commonly used, that is the filter press, or we can also call pressure filter, and rotary drum filters also known as vacuum filter. So, the filter press they are mostly applied in a batch operation, and vacuum filter is applied in a continuous setup. So, a filter press is often employed at a small scale separation of bacteria and fungi or any other solid particles, and for the large scale filtration rotary drum filters are usually applied. A common filter medium is cloth filter. It can be made of canvas, wool or synthetic fabric, even metal or the glass fiber. So, it is simply going to have a simple filter medium for the separation of solid and liquid. So, this is a plate and frame filter press. So, what we are seeing over here is, this is a plate, these are the plates, and around the plate they are covered with filter cloth. So, what is happening, there is a channel inside the plate. So, it is entering here, and because of the pressure it will go from one plate to the other plate, so on so forth, and finally it will exit from here. And this is the, you are applying the pressure, so that you compress it, so that it will apply certain pressure, so it will pass through the filter and come out. And these are the filter cloth, as I told, on each plate is covered with the filter cloth. So, once you pass through the liquid, what happens, the solids will get deposited over the cloth, and after certain time duration there will be a thick layer of solids will be there that need to be removed or cleaned. And the thick layer of solid is also called filter cake. In the case of a rotary vacuum filter, so it is having a cylindrical tube, and in the center you are applying the vacuum. So, you are having a suction here, and there are perforation in such a way that they are connected to the surface of the rotor, and rotor surface is covered with the cloth. These are the hollow spokes, and it is covered with a cloth. Now, what is happening? It is continuously rotating. So, this is the feed, and once it is rotating in this way, so it is happening here, once it is coming in contact with the liquid, liquids are getting sucked and cake is deposited on the surface. It is coming here, and there is a cake removal blade or knife which removes the cake. So, you just see from this region to this region there is no cake. So, your drum surface is ready for the next batch. So, that is why we are able to operate this in a continuous mode, because there is a provision to remove the cake in a continuous manner. So, filter press they are batch filtration system and used for harvesting microorganisms from fermentation, including the preparation of blocks of Baker's yeast, recovery of protein precipitate and dewatering of sewage sludge. And as I told, here the cakes will be deposited, so they must be periodically opened and cleaned. While in the case of rotary vacuum filter, they used for continuous filtration and used for harvesting, let us say, fungal mycelium during antibiotic manufacture or Baker's yeast production, and in dewatering during wastewater treatment. So, only difference is this is a small scale batch filtration system, and this can be used for the continuous filtration process. So, you can just see this is a more detailed schematic of rotary drum vacuum filter. So, you just say this is rotating like this, and there are suction pipes are there. So, what is happening once it is coming in touch with the liquid? So, the cakes are getting deposited. In addition, there is also provision for the washing of the cake to remove some impurities. Then here again you can dewater it, you can remove the water, and there is a scraper which removes the cake. So, in this way it is cake forming, washing, cake dewatering and cake discharge. There are 4 sections, you can say: cake forming, cake washing, cake dewatering and cake discharge. The typical drum size, it can be 0.5 to 3 meter in diameter, and it rotates slowly because you need to give sufficient time for the deposition of cake, 0.1 to 2 rpm. Filter cloth covers drum which is partially immersed in agitated broth reservoir. So, what are the steps? First is the immersion. The drum enters to the liquid and vacuum applied. Liquid passes through the cloth and solids form filter cake. The next is washing. Spray liquid washes the cake and was collected separately. Then dewatering, then continuous vacuum removes more liquid. Then discharge, vacuum is off and their cake are scraped using certain arrangement. It may be a knife, it may be string, it may be a scraper. Remove the cake, and then once this is done, you can repeat the cycle as drum re-enters into the broth. So, what is the theory of filtration? In this case, the driving force is pressure difference. So, it says the rate of filtration is 1 upon A dV upon dt is proportional to delta P is the driving force. And what is the resistance? There are 2 resistances. One is filter medium itself is causing certain resistance because you are using certain cloth, and with time there will be deposition of solid, or that is you are calling as a cake. So, there will be cake resistance RC. So, these are the 2 resistance. A rate of filtration is directly proportional to delta P driving force and inversely proportional to the resistance. A is the surface area of filter, delta P is the pressure drop, mu is the viscosity of filtrate, Rm is resistance of filter medium, and Rc is resistance of the cake. So, when you are starting the filtration, in that case Rc is 0. So, in that case the filtration rate is highest at the start because you are having the Rc is 0, and slowly this filtration rate declines due to formation of cake. Then particle orientation in initial cake deposit affect the structure and permeability. So, one option is you can further increase the driving force delta P. So, if you increase the delta P, so there is a risk of filter cloth plugging, and it may be the tearing of it can damage your filter cloth. Now, cake resistance, as you know, this cake resistance should be proportional to the what is the weight of cake upon area, and this proportionality constant is known as alpha, that is specific resistance of cake So, it says alpha, and mass of cake can be written in terms of weight of cake deposited per unit volume in the concentrate. So, it says let us say concentration into volume, it becomes the weight of cake upon area. So, now if you remember the last equation, it was 1 upon A dV upon dt equals delta P upon mu Rm plus Rc, and this can be written as delta P upon mu viscosity Rm, and Rc we are writing as alpha C V upon A. Now, we can rearrange it and integrate it. So, what we will get it? It will be dV Rm plus alpha Cv on A mu is equal delta P A and dt. So, if you integrate it, you will be getting this Rm into V plus alpha C V square upon 2 A, this equals delta P A T upon mu can be shifted this side mu. So, this is the equation we get for the filter operation. Now, this can be further rearranged. So, for that we are using two terms, one is V naught, we are taking V naught as defined as Rm A upon alpha C. So, basically V naught is related with filter medium resistance, and one more term we are using K. K is related to delta P A square upon mu alpha C. So, this mu alpha C, it may be related with this cake resistance. Now, by putting this value V naught and K, this equation can be simplified as V square plus 2 V naught to K into T. Now, we can divide by V this side and K this side. So, we will be getting V upon K plus 2 V naught upon K equals T upon V. So, if you can plot, you are having already the data T upon V at y axis and V at x axis, then the slope will be 1 upon K, intercept will be, the slope will be 1 upon K and intercept will be 2 V naught upon K. In this way, we can get the value of V naught, and which can be used to calculate the filter medium resistance. So, we can see in the filtration what we discussed is, we are separating the solids from the solid liquid mixture and flow process through the medium, and solids retain, they are called as filter cake. Driving force is the filtration pressure drop delta P. What are the factors affecting the filtration? If there are incompressible solids in the low viscosity fluid, or there are some crystalline material, so they are easy to separate. But if the fermentation broth is having a small gelatinous cells or viscous or non-Newtonian fluid, so they are difficult to filter. Filter cake property, typically the microbial cakes are compressible, and with the porosity decreases with the pressure, and generally they cause results in lower filtration rate and product loss. So, the cake need to be frequently removed. Operating condition usually operates in antiseptic in fermentation broth, and must be this efficient and reliable to avoid any contamination and product degradation, because once you are separating the solid, means your product may be supernatant. So, there should be no risk to contaminate your product. So, typically what happens when there is a clogging, let us say this is a filter cloth, you are passing your broth and this is a filtrate, and here you just see there is a cake is deposited here. So, one option to address this is to apply the filter aids. One example is diatomaceous earth, and typical size is in the range of 10 to 25 micrometer, and they have very high porosity and 85% void space. So, it improves the liquid flow and filtration rate. How it can be applied? It can be applied as a pre-coating. So, you can just see it is a pre-coated on the filter. Other option is you add to the broth 1 to 5%. So, it increases the porosity. You just see it increases the, because in between there will be filter heads, porosity of the formed cake. So, it prevents the filter blockage and it improves the filtration efficiency and filtration rate, but at the same time it is a costly. So, the minimum quantity must be optimized. It also absorbs the liquid because it is having 85% porous, and many times when you need this clear filtrate. So, the color of this diatomaceous earth may come into the liquid phase, and further there is a challenge of the waste disposal issue, because this diatomaceous earth is now mixed with the biomass. So, once it is difficult to separate the biomass and this filter head, so it is not suitable if your product is intercellular, because in the case of intercellular you need to separate the cell and then again you go for the cell lysis. So, next method we are going to discuss is centrifugation. So, centrifugation is technique that uses centrifugal force to separate the components of mixture based on their density. So, solids have more densities, liquids have comparatively lesser density. So, heavier particles, particularly solids, moves outward faster than the lighter one when rotated at high speed. Application, they used to separate the cells. In addition, if it is intercellular product, this method is also applied to separate organelles or debris. They can also apply to separate proteins, even nucleic acid at very high speed. So, what is the size range? A typical size range is 100 to 0.1 micrometer. So, there are three commonly applied industrial centrifuge. One is the tubular, second is a multi-chamber bowl centrifuge, and other one is a disc stack centrifuge. In addition, there may be this screw decanter centrifuge. So, they have different design concept, but the main principle for all three is you have to rotate. You just see they are rotating here. Once you rotate, the centrifugal force will be applied. Now, it is different mechanism how you are separating the solids and liquids. For example, if you see this tubular bowl centrifuge, so it is having a simple configuration and widely used in the food and pharma sector. Feed enters at the bottom and accelerated to rotor speed, then it moves upward. So, what will happen? The particle will try to go outside to the bowl wall and solids are collected separately. So, if you have higher feed rate, so you may have the thick liquid layer and that may lead to the poor separation. So, one need to have the optimum rotation speed. The capacity limited when sediment thickness reaches liquid overflow. So, at that time we need to remove the solids and use for difficult separations requiring centrifugal force in the range of 13,000 to 16,000 G force. So, you just see this is a particle trajectory, we are going towards the wall, the feed rate is going like this and this is the liquid flow, they are going out. In the case of disc stack ball centrifuge, so disc, they are conical metal sheet stacked with 0.3 mm Saturn clearance, and liquid split liquid into thin layer for the better separation. So, it is splitting the liquid into 3 layer. So, here what is happening, the happy components, they move outwards and then further they are slide down to get removed from here, and liquid flow inwards and discharge at the top. So, feed is coming here and you just see liquid is again getting discharged at the top. Heavier liquid with solid discharged at the top, maybe through nozzles. A typical force range is 5000 to 15,000 G force, and effective when density difference is in the range of 0.01 to 0.03 kg per meter cube, and this is typical value of minimum particle size separated is 0.5 micrometer. So, it says as centrifuge size increases, the operating speed can also decrease, and then maximum centrifugal force also decreases. Now, how to separate the solids? One option is you can remove the manual or continuous discharge through peripheral nozzles, or intermittent discharge, there can be valve arrangement. In addition to centrifuge, now there are ultra centrifuge are available. They are kind of a narrow tubular bowl to produce extremely high force, 10 to the power 5 to 10 to the power G force. They apply it to separate fine precipitate recovery, emulsification breaking, colloid separation like ribosomes, mitochondria and certain proteins. Commercial use for the, let us say, for vaccine production, viral particle separations. Usually it operates in a batch mode. Now, what is the theory of centrifugation? So, first let us consider a solid particles settling in a liquid by gravitational force. So, you are having a solid particles settling in a liquid. So, they are experiencing the gravitational force F g. In addition, they are experiencing drag force and buoyancy force. There are two other forces are being applied. The gravity force, it pull downward due to particle density, buoyancy force, upward force due to displace the liquid. So, we are having upward force F p, and drag force resistance due to fluid viscosity, it is again will be F d, drag force. So, the velocity of particle increases as it falls and reaches to a constant velocity, that is known as terminal velocity. So, terminal velocity u naught reaches when the forces are balanced. So, it says F g will be equals to drag force plus buoyancy force F b. Now, F gravitational force, it can be defined as m g. So, mass you can write in terms of volume into density, that it will be pi by 6 dp cube into density particle into g. So, this is m g. Buoyancy force F b, it will again depend on the mass, pi by 6 dp cube, but density now it will be fluid density rho f into g. So, these two forces, gravity force and buoyancy force, is straightforward. Now, there is one more force, that is a drag force F d, and this is defined as drag coefficient C d upon 2 rho f density of the fluid u naught square into A. So, here rho f is the fluid density, u naught is the relative velocity between fluid and particle, or you can say terminal velocity of a particle. A is the cross sectional area of the particle perpendicular to the direction of the flow. Now, this force or the drag coefficient, we can see they are defined if Reynolds number is very low by the Stokes equation. So, its CD is 24 upon Reynolds number. Now, what was the FD was CD upon 2 rho of u square A, rho of u naught square A. So, here you can put CD as 25 upon RE, and if Reynolds number lies in this range, then CD is determined like this. So, let us say what is RE? RE is rho density V d upon mu. So, if you incorporate this CD value, the drag force now it becomes 3 pi mu dp into u naught, or you can say 3 pi mu diameter of the particle and the terminal velocity. So, now we will put these three forces here. This is the rho p, means gravity force, F g, rho f, this is a drag buoyancy force, this is a buoyancy force, and this 3 pi rho dp upon u naught, this is a drag force F d. Now, from here this is the u is here. So, if you just rearrange it, this will be 3 pi mu dp to u naught equals pi by 6 dp cube is common in both the cases, rho p minus rho f into g. Now, if I take this pi will be cancelled out here, dp will be cancelled out, now it will be dp square. So, now you are getting u naught as dp square rho p minus rho f into g divided by 618 into mu. So, it says it is proportional to delta rho. You can say u naught is proportional to delta rho, change in difference, and inversely proportional to the mu, and also proportional to dp square and proportional to gravitational force. Now, in case of centrifugal acceleration, what is going, we are going to change? We are going to change g with centrifugal force. What is centrifugal force? Is omega square r, and omega is angular velocity of rotation, is also defined as 2 pi n into r. N is the rotational speed, rpm, r is the radius. So, whatever expression we have derived, so u naught, now this will be dp square rho p minus rho f, and the gravitational force will be replaced by the centrifugal force, gamma square r upon 18 mu. So, in this way we calculate the terminal velocity in the case of gravity settling or in the case of centrifugal force. Therefore, the increase in the acceleration by centrifugal force speed up the settling process. Now, there are certain operational issue, particularly with industrial centrifuge. It generates the heat because it is operating at the high speed. So, many times you need to see there are cooling centrifuge or good ventilations are required. Further, this if you are using with aerosol, they can cause infection or allergy. So, you need to have this isolation cabinet. The efficiency factor better when the density difference is large because it is directly proportional to change in the density. Particle size is large, dP square, and viscosity is low because inversely proportional to the viscosity. Centrifuge radius is large. So, if centrifuge radius is large means centrifugal force is large and speed is high. So, omega square r. You just see the same. So, it says u naught is dP square, particle size is large, that density difference is large, rho p minus rho f, liquid viscosity is low 18 mu, centrifugal radius is omega square into r, speed is high and centrifuge radius is large. Challenges with biological solids: some solids, small particles, high viscosity and density similar to liquid, its separation becomes difficult, and there are certain difference between laboratory and industrial centrifugation. Particularly small lab centrifuge works at high speed, while industrial scale has a mechanical stress limit. So, that is the scaling limitation. This mechanical stress is proportional to radius square. So, larger centrifuge must operate at a lower safe speed, or we can have multiple batches of the centrifuge. Industrial need: there is a requirement for continuous throughput, requires specialized centrifuge design. Now, next topic is sedimentation. So, as we have already seen, when a particle is settling in a liquid, there are three forces are working: gravitational force, this drag force and buoyancy force. So, it says when it is settling by the gravity, the sedimentation is a process of allowing the particle in suspension to settle down of the fluid which they have entertained. Now, what is driving force? It is based on the gravity. When denser particles settle at the bottom over time. So, you can just see we can apply the same equation over here. So, the settling velocity is proportional to change in the settling velocity is proportional to difference in density, particle size, gravitational force and inversely proportional to the viscosity, and they are also used in the wastewater treatment and initial separation of biomass from the fermentation broth. So, we will not discuss sedimentation in more detail, rather we will see one example based on the sedimentation. So, it says sedimentation tank of height 150 centimeter is used in a conventional activated sludge process to separate suspension of spherical granular sludge particle diameter of 0.8. So, it is a dP is 0.8 mm or 0.08 centimeter. The liquid viscosity mu is 1.5 Cp or 0.015 gram per centimeter into second. The density difference delta rho is directly given as 0.08 gram per centimeter cube. If the particle reaches their terminal velocity instantaneously, what is the biomass settling time in the minutes? So, we have to find how much time it will take to the settles. So, for that you need to first calculate the settling velocity. At terminal velocity is dP square delta rho into g upon 18 mu, and g we are taking as 980 centimeter per second square. So, we are getting terminal velocity as 1.858 centimeter per second, and once we know this velocity, now we know what is the height of the tank is. Height is 150 centimeter. So, time will be your height upon velocity, and that you are going to get 1.35 minute. So, it will take 1.35 minute to settle down. So, with this this is the summary what we have discussed so far, the overview of separating the insoluble, particularly solids. It removes the biomass, insoluble particles or some other macromolecules. It is essential for both soluble and intracellular product recovery. So, many times some pre-treatments are done, a heat treatment to remove the separation efficiency. Many times we need to do the pH and ionic adjustment or addition of coagulant and flocculant for the easy separation of those solid particles. Now, biomass can be your product. So, you need to separate the solid, that is a major step, or a soluble compound as a product. You remove the solid, then you take the liquid for the next step, or intercellular, then you have to go for cell disruption and you remove the cell debris again following these three methods, that is filtration, centrifugation and sedimentations. So, with this I will stop here. Thank you so much.